Hi. I'm Stephanie Beauregard. I work here at Booth and Associates as the manager of the Financial Services Division and talking about the electric vehicle rates. So things to consider, and Josh was a good lead into this, managing the impact of your additional capacity. Also recovering costs for the additional facilities. And you want to be able to design rates so that any change in behavior from your customers so they can save on their retail bill equates to you saving on your wholesale power costs and other system costs. We're going to cover residential customer charging, commercial customer charging, and then EV charges, whether they're customer owned or utility. So why is managing the impact of that capacity so important? For most of you, your power cost accounts for more than half of your total utility expenses. And of those power costs, your capacity cost is more than half of that. And that covers your demand cost as well as transmission costs. Anything that's based on $1 per kW. And that capacity cost can be based on as little as a single hour in the year. Up in Virginia, there are transmission costs that are based on your last year's annual peak hour. So that's 1 hour. In the PJM area, it's based on the 5 highest summer peaks. A lot of utilities here in North Carolina, your demand is based on a monthly coincident peak hour. So that's 12 throughout the year. 1 hour per month determines what your demand costs are. There are also some contracts that look at the 20 highest summer peaks. So it's a little bit more. So whereas your energy is $1 per kWh, and it's the same whether you sell that kWh at 8 o'clock in the morning or 2 o'clock in the afternoon, on the demand side, it really matters what hour of the day we're talking about. So for residential EV charging, I have 80% of EV chargers at home. Apparently it's up to 85. The added system load for a level 1 charger is between 1.4 and 1.9 kW. Although more and more residential customers are getting a level 2 charger, which is 2.5 to 19.2 kW. Typically, it's around 7 kW. What you want to do is encourage off-peak charging. The way to do that is through time of use rates. There are also subscription rates, and there are also monthly credits. And I'll give examples of each of these. So currently some rates that we've designed are time of use rates. There are 2 block rates and 3 block rates. The number of blocks refers to the number of energy blocks. See, in a 2 block rate, there is a daytime rate and an overnight rate. And what you want to do is make the differential between those 2 rates enough that people are encouraged to plug in their EVs overnight, or at least program them so they start charging overnight. These are approximate hours. You may need, I've seen some overnight that are later in the night, like midnight, 1 a.m. to 6 a.m. Some of them end at 5 a.m. Just depends on when your peaks are occurring, and that's what you want to design those rates around. 2 block rates, Wake has a 2 block rate, and I think the differential is 2 cents between the daytime and the overnight hours. A lot of co-ops will have 3 block rates where there is an on-peak, and your on-peak hours between winter and summer are different. Obviously, peaking in the morning hours in the winter, afternoon hours in the summer. And then there's a super off-peak, which are those overnight rates. And then off-peak is any other time. I've designed quite a few of those where the super off-peak rate simply covers the cost of energy plus losses. We've also designed these to be revenue neutral at some point. So we'll look at your standard rate and then design this rate so that somebody without an EV is still paying the same. And then that encourages the customer, well, if I charge on peak, it's going to cost me a lot more. So I'm going to charge during overnight, and it's going to cost me less. Excuse me, cost me less. Another option with these rates is, do you include weekends and holidays? Right now in North Carolina, the peaks that are billed cover 7 days a week, although some people still opt to only make their on-peak hours during the week, Monday through Friday. I can tell you in 2022, there's only been 1 peak on a Sunday. In 21, there was one peak and a Sunday, but in 2020, there were 3 that occurred on a Sunday. So it's just a matter of managing that risk and customer satisfaction. More complicated time of use rate. This is introduced by Duke. It's called an advanced time of use rate, also known as critical peak pricing. Looks similar to the 3-part rate. This was mostly developed for solar, but there is a discount period, so it is suitable for EV customers. And the difference, and they do have an on-peak rate, but they also have what's called critical peak pricing. So this can be up to 20 days per year, and the hours are the same as the on-peak hours. So it's the very hottest of your summer days, the very coldest of your winter days. And the way it works is they will notify you of if it's a critical peak day. And the challenge for the utilities there is, can you communicate that to your customers so that they can manage their load? And can you program it into your billing system? Because that's law. Because currently right now, they program time of use rates by saying, okay, between this hour and this hour, you're going to charge this rate. But with this rate, you'd have to be able to program in, these are the critical peak days, and you need to adjust your bills accordingly. Right now, the critical peak rate for Duke is about 35 cents, and on-peak rates are about 20 cents. So there is quite a differential there. Other option are subscription rates, where a flat monthly fee is charged for a set amount of kilowatt hours. If a customer uses more than those kilowatt hours to charge your electric vehicle, they're charged at the standard rate. And the average rate, the dollar per kWh on the set monthly fee, is lower than the standard rate. This requires off-peak charging. The advantage of this is it's very simple. The con to this is confirming that people are charging off-peak. One example is that a co-op is putting in the charges for their customers, and then during their on-peak hours, they change the voltage from a level 2 to a level 1. So it does have less impact to their system, even if people choose to charge on peak. Do you want to add anything?
Go. Yeah.
Okay. And then the third option I've seen is a monthly credit. I know Rappahannock up in Virginia is doing this. They bill everything at the standard rate, and then they give a credit. That credit could be a set monthly amount or a dollar per kWh charge. The advantage of this is that you don't need a separate rate for your EV customers. The disadvantage to this is confirming that they're charging off peak. One way to do that is you can meter it separately, which is costly, and although that would give you the exact information you need, everybody's been reluctant to do that simply because of the cost. I know Rappahannock at first tried getting the data from the car of when they were charging, but there were a lot of incompatibilities with the data. And they charge or they credit a $7 monthly, sorry, they give a monthly $7 credit for their accounts. And they're simply going to audit those accounts periodically to make sure that people are charging off peak. On the commercial, anybody have questions about residential charging? Yes.
Say, can't you confirm that they're charging off peak? I guess if you set up your meter, your whole home metering for time of use, and the reason I say that is Cobb EMC in Georgia is now saying free charging. The way they do that is they credit 400 kilowatt hours a month, but only in the block between midnight and 4 a.m. So you get 400 free kWh a month, but it has to be during that time. So what they do is they set up a time of use block, set that out, and then they just subtract 400 kWh from that block at the end of the month. And
that sounds like a good idea.